All right, well, you did it. You made it. This is your last video. This is for review for Unit 10. All right, let's go through it. Number one, a line has a slope of 7/9, and we need it to be perpendicular to this line. What's the slope perpendicular? Remember, flip it and change the sign. So our new answer will be m equals -9/7. Number two, a line has a slope of 5/8, and it wants a parallel slope to that. Well, that's just 5/8. You remember, perpendicular lines are flipped and reverse. Parallel lines must be the same. All right, number three, what is the slope of all lines perpendicular to 3? So we want it perpendicular to 3x plus 7y equals -7. We're just going to solve for y, and we're going to, let me turn the slide on here. We're going to solve for y, and then we're going to flip it and change the sign. Okay, so minus 3x on both sides. 7y is equal to -3x minus 7. Divide by 7 all the way across the board, and we get y is equal to -3/7 x minus 1. Now I want to look at this, and I want to flip it and change the sign. So my slope for perpendicular to this line would be +7/3. +7/3. I'll go ahead and box all my answers. All right, number four. Number four says, what is the slope of all lines parallel to this line? So parallel, once again, means same slope. So we have 3x minus 4y equals 24. We are going to move our x, so minus 3x. Now we have -4y is equal to -3x plus 24, because it's positive, divided by -4 all the way across the board. And we end up with y is equal to +3/4, because it's negative, minus 6. So we want it parallel to this slope, which is just this slope, m equals 3/4. All right. Number five. Number five says, which of the following best describes the lines y equals -8 equals 3x and 4 minus 4y equals 12x? They want to know parallel, intersecting, perpendicular, or skew. Skew you won't talk about until you're talking about different planes. Here's what a skew line is. Ready? We have one line on one plane going this direction, and then we have another line on another plane going this direction. See how they're not touching? But they would intersect if they were on the same plane, right? So skew lines are in three-dimensional space. We have one line, let's call this one plane, right? My paper. This line on this paper is 1. Now, my pen is on a different plane. It is not intersecting that line, but they are crossing, but they're not intersecting, okay? Another version is if I had the line going at a downward angle, okay? I'm not going to cross that line either. It's on a different plane. All right. Intersecting lines just mean they intersect at any angle. It could be that, it could be that, it could be whatever. But perpendicular are very specific. They intersect at 90 degrees, or they intersect this direction at 90 degrees. All right. So let's do some math. Y minus 8 equals 3x, and 4 minus 4y equals 12x. So we're looking for our slopes. We're going to add 8 to both sides on this one and get y is equal to 3x plus 8. Then we're going to subtract 4 on this side, and we get -4y is equal to 12x minus 4. Divide everything by -4, and we end up with y equals -3x plus 1. Now we have 3x and -3x and +3x. Those lines will intersect, but will they intersect at 90 degrees? No, because they're not flipped. They're not reciprocals. So the answer is B. Number 6, which of the following best describes the lines x equals 8 and y equals 1? You remember these are Hoy-Vux lines, right? So Hoy lines are horizontal with a 0 slope, and they always start y equals. and they cross the y-axis. Vux lines are vertical lines, undefined slopes, and they always start x equals and they cross the x-axis. So the easiest way to do this one is to actually draw a picture. Our first one says x equals 8, so I know that 1, 2, 3, 4, 5, 6, 7, 8. It will cross right here. It's a vertical line. And y equals 1. This one right here. So what's the best way to describe these two lines? These two lines are definitely perpendicular. Okay, one has a slope of 0, 0 over 1, and one has an undefined slope, 1 over 0. Negative, positive, doesn't matter. Okay, this can't happen, undefined. This is 0. All right, so number 6 would be C. All right, number 7 says, which of the following systems represents a pair of lines are perpendicular to each other? Ooh, all right. So, I'm going to hit pause real quick 1 second, get my stuff organized. All right, we're looking at number 7, which of the following system represents a pair of lines that are perpendicular to each other. As a reminder, if you look at all these questions, they're all in standard form. You remember standard form? Standard form is ax plus by equals c. And when things are in standard form, we can find the slope by doing negative a over b. Okay, negative a over b. That's how we find our slope. So we can do that really quickly with these. If we do negative a over b for a, it's negative a over b. So negative 3 over 2 and what is that? Negative 2 over 3. Negative 2 over 3. Those are intersecting. Those aren't perpendicular. Those aren't parallel. All right. B says negative 3 over 2 and then positive 3 over 2 because we have to do negative, negative, right? Those are opposites, but they aren't reciprocals. All right. C says negative 3 over 2. And the second one for C says positive 2 over 3 because negative, negative is a positive. That is an opposite reciprocal, so the answer will be C, but let's look at D just in case. Negative 3 over 2 and positive 3 over 2. Those are opposites but not reciprocals. All right. I hope that was a little bit fast for you. Number 8, or figured out a faster way to do it. Number 8, for what value of k will the graph of y equals kx minus 5 be perpendicular to the graph of 4/5 x plus 7? So we need k to equal something that is opposite and reciprocal of 4/5. While reciprocal is 5/4. Now opposite, make it negative 5/4. So the answer will be negative 5/4 for number 8. Number 9, by the way, that was number 7. Number 9. Determine the coordinates of a midpoint of a line segment with endpoints negative 2, negative 4, and 6, negative 3. Cool. Well, if you remember, midpoint is just the average. So we're going to do the average for the x's and the average for the y's. So we have negative 2 plus 6 over 2 and negative 4 plus negative 3 over 2. Negative 2 plus 6 is going to be positive 4. Positive 4 over 2 is 2. And negative 4 plus negative 3 is negative 7 divided by 2 is negative 3.5. All right. Number 10. One end of the segment has coordinates blah. The other end of the coordinate has blah. What is the midpoint? Once again, it's just an average. So add two things and divide it by 2. So we get negative 7. We get negative 7 plus 13 over 2. And 18 plus negative 10 over 2. Oops. Negative 7 plus 13 gives me, what is that? Positive 6. Positive 6 divided by 2 gives me 3. And 18 plus negative 10 is positive 8, divided by 2 is positive 4. Number 11, find the midpoint of a segment whose endpoints are blah. Once again, it's just the average. So 3 plus negative 5 over 2, and 2 plus 6 over 2. This is going to give me negative 2 over 2, which is negative 1. 2 plus 6 is 8, divided by 2 is 4. That will be my answer. Number 12. Number 12. L is there, M is there, represents the coordinate plane. Find LM. So we want distance formula. Okay, distance formula is the square root of the differences of our x's squared. So I'm going to do 1 minus negative 3 squared plus the differences of our y squared. Negative 2 minus negative 5 squared. Okay? 1 minus negative 3 is going to be 1 plus 3 is 2. Sorry, 1 plus 3 is 4. 4 squared is 16. Negative 2 plus 5 is going to be 3. 3 squared is 9. 16 plus 9 is 25, so we're doing the square root of 25, which is 5. It's not positive or negative 5 because we don't have negative distances. So we're going to say LM without the line on top equals 5. So LM with the line on top is calling it line segment LM. This is giving me a value, so I don't use that line segment portion. I'm not naming it to give a value. I'm just giving a value. All right. Geometry is real specific like that. Number 13. Got a little bit of time left. Number 13, what's the length of the segment blah? So we're going to do the square root of our distances squared and add them together. So 5 minus negative 7 squared plus negative 13 minus 22 squared. And we get 5 plus 7, which is 12. Squared is 144. Negative 13 minus 22. Negative 13 minus 22 is going to give me negative, what is that, 35. Ooh, I can't do that in my head. And don't forget, let me make sure you can see this. Don't forget, whenever we have a negative value, we always wrap it in parentheses. So it's negative 35 in parentheses squared, which is 1225. Add them together, and I get 1, 3, 6, 9. Is that a perfect square? Yes, it is. So equals 37. So we will say, no, that's all we say, is it equals 37 units. All right. Number 14, approximately what is the length of JK? Approximately what is the length of JK? All right. Let's see, I've got enough time to do this one. So we're just counting our x's and counting our y's. We're going to make a triangle, right? So 14, it says JK is the shape. So we're going to count down this way to find this length. We're going to count down that way to find that length. Okay. All right. So down 1, 2, 3, 4, 5, 6, 7, 8, 9, I believe. Yeah, 9. So it's 9 units this direction. And 1, 2, 3, 4, 5, 6, 7, 8 units this direction. So we have 9 squared, the square root of 9 squared plus 8 squared, which is, what is that, 81 plus 64. Add them together, and we get 145. The square root of 145, it says approximately, so I'm just going to type in the square root of 145 in my calculator. It gives me 12 point something. So it's approximately 12, which is A. All right. And I'm going to stop here and continue on another video to finish up.